Well, welcome back. We will be starting Unit 1, Lesson 9, page 25, finding linked values in ratio tables. So again, draw a line in your black notebook, write Unit 1, Lesson 9, finding linked values in ratio tables, page 25. And it would be great if you added the date. I recorded this video on September 21st. So let's take a look at the directions for number 1. It says make a ratio table. Make a ratio table for each situation. Be sure to label the columns. So let's take a look at number 1. Noreen makes 2 drawings on each page of her sketchbook. Tim makes 5 drawings on each page of his sketchbook. So for number 1, I'm just going to move down here a little bit. We have 2 columns. It wants us to label the columns. So if you look at column 1 and column 2, that's where we will start. All right, so we have Noreen for column 1. So let's go ahead and add Noreen. And Tim. And it's 2 drawings on each page and 5 drawings on each page. So your ratio's 2 to 5. For every 2, Tim has 5. All right. So the next step would be to complete the ratio table. So over on the left, plus 2. Over on the right, plus 5. So you would start out with 2 and 5, plus 2, 4, plus 5, 10. And then all the way down, you can go ahead and fill it in and finish your table. Two, 4, 4 plus 2, 6, 10 plus 5, 15. And then this bottom question here says the linking unit is what? What's linking Noreen to Tim? Well, it's 2 to 5 what? 2 to 5 pages. So your linking unit for this problem is pages. So go ahead and write that below. All right, let's look at number 2. It says 2 bands marched onto the football field. Band 1 marches on in rows of 5, and band 2 marches on in rows of 7. So again, ratio table. We have band 1 and band 2. So above your first column, put band 1. Above your second column, put band 2. So band 1 marches in on rows of 5 and band 2 on rows of 7. So it's your ratio would be 5 to 7. Now here you have a third column, which is titled already for your rows. So in row 1, it'd be 5 to 7. In row 2, it would be 10 to 14, and so on. So row 3 row 4, row 5, and row 6. 5, 10, 15, 20, 25, and 30. 6 times 5 is 30. 7, 14, 21. 7 times 4 is 28. 7 times 5 is 35. And 7 times 6 is 42. So in the 6th row, band 1 would have 30, and band 2 would have 42. What's the linking unit for this problem? And they would be rows. So on the line down below, write rows. All right, I'm going to show you what number 3 would look like, but you don't have to do number 3. But let's take a look at number 1 and number 2 and number 3 completed. So here you go, pages, rows, and in the third one you have John and Joanna, 7 to 4, and then the linking unit is a period of time, because if you look at number 3, it says John can plant 7 tomato vines in the time it takes Joanna to plant 4 tomato vines. So your linking unit is a period of time. All right, let's go ahead and move on. All right, so continuing on with number 4, it says the ratio of Noreen's drawings to Tim's drawings is what to what? Looking at problem 1, table 1, Noreen's and Tim's. Noreen was 2 and Tim was 5. So the ratio unit drawing would be 2 to 5. If you go back, you can see 2 to 5. The ratio of people in band 1 to the people in band 2 is blank to blank, written as 5 to 7. So if you look, 5 to 7, so on the line, for number 5, write 5 to 7. Now, they are showing you that it can also be written 5:7. That's just another way to represent that ratio. And then 5b, still looking at table 2, if band 1 has 15 people on the field, band 2 has how many people on the field? This is what row? So if you look at 15 for band 1, so let's go back to the table, 15 for band 1, then band 2 would have 21 on row 3. So you have 21 people on the field. This is row number 3. Okay? I'm just going to show you number 6. This is with John and Joanna, so you don't have to copy number 6 down. But again, 4 and 5 and 6 would look like this. And let's talk. John and Joanna's tomato vines are in the ratio of 7 to 4. We write this as 7:4. John plants 42 vines, Joanna plants 24. And if Joanna plants 8 tomato vines, John plants 14. And that just comes from the table here. And then right here. All right, let's continue moving on. On page 26, still continuing on with recognizing ratios and non-ratio tables, how they link the values. There are a couple definitions we'll talk about here in a little bit. Let's look at the directions here. Recognize ratio and non-ratio tables. Discuss which are ratio tables and why. Tell ratio stories for each ratio table and tell what the linking unit and the column labels are for each story. So here you have 7A, 7B, 7C, 7D, and we are to figure out the linking unit and the labels for each column. Okay, so 4 to 7, 3 to 5, 2 to 9, 2 to 3. That's what we're looking at. Now, what we need to figure out is if it is a constant increase. So, looking at the 4 to 7 first, 4 to 7, 8 to 14. It's going up by 4 on this side, up by 7 on that side, or multiplying by 2 and multiplying by 2. Okay, so 4 times 2 is 8. 4 times 3 is 12, or 4 plus 4 plus 4. 7 times 2 is 14, or 7 plus 7 is 14. 7 times 3 then would be 21, or 7 plus 7 plus 7. So this rate right here shows a constant increase. So that it says right here, A and C are ratio tables because they show constant increases in each column. So let's look at B here real quick. You have 3 to 5, and then 3 to 6. So it's going up by 3 or multiplying by 2. But 5 times 2 is 10. 5 plus 5 is 10. So that's why B is not a ratio table. And then it says that C is a ratio table. So let's look. 2 to 4, up 2 or multiply by 2. 9 to 18, up 9 or multiply by 2. 4, 2 times 3 is 6, or 2 plus 2 plus 2. 9 times 3 is 27, or 9 plus 9 plus 9. So C is a ratio table as well. You don't have to copy any of this down, just know that you're responsible to figure out if it is a ratio table or a non-ratio table. All right, the two definitions. Basic ratio, a ratio in simplest form. I do want you to copy the example. So if you would, please put basic ratio and then this example right here. The basic ratio for 25 over 30 is 5 over 6. The basic ratio for 12 over 24 is 1/2. Now we're dealing with ratios, but what you're really doing is, if you think of it as a fraction, you're representing that fraction in lowest terms. So you're recognizing what factor would go into 25 that would also go into 30. 5 goes into 25 5 times. 5 goes into 30 6 times. And the same thing with 12 over 24. You're recognizing what factor would go into 12 and also 24. 12 goes into 12 once, 12 goes into 24 twice. So you're really just representing these basic ratios similar to how you would represent a fraction in its lowest term. And then equivalent ratios, again, thinking of them like fractions, it says ratios that represent the same comparison. Equivalent ratios have the same basic ratio. Okay? So it's just saying that these two ratios right here, 12 over 24, is equivalent to 1 over 2. That's all it's saying. It's just representing one of them as its basic ratio. Okay? So again, what I highlighted in green, starting with basic ratio and the two examples, copy in your notebook. And that's it. All right, so let's take a look at this. Problems 8. Basic ratios and equivalent ratios. A basic ratio has the least possible whole numbers. 4 to 7 is basic ratio because no whole number except 1 divides evenly into 4 and 7. So 4 to 7 is at its simplest form, if you want to call it that. Equivalent ratios are made up of multiples of the basic ratio row. Equivalent ratios written as 8 to 14 could also be represented as 20 to 35 or 8 to 14, 20 to 35. For the tables that are ratio tables, use the tables to write 4 pairs of equivalent ratios. So let's take a look at that. So for number 8, they're actually wanting you to go back and look at look at A and look at C. Those were your two ratio tables. So if you look at table A, 4 to 7, 8 to 14. If you look at table C, 2 to 9, 4 to 18. So now I'm just going to jump ahead. For the tables that are ratio tables, use the tables to write 4 pairs of equivalent ratios. So on this one, all they really want you to do for number 8A is put 4 to 7. Okay? And then, jumping back to this page, next one, 8 to 14, and then also 12 to 21 are all equivalent. So 8 to 14 and 12 to 21. 8 to 14. Well, I guess probably should have put that on the other line. 8 to 14 here. I think it was 12 to 21, I believe. Let's just take a look at A here. So if you move over, you have 4 to 7 is the same as 8 to 14, and what actually they did, oh man, I must be missing something here. 4 to 7, 8 to 14. Oh, looks like they're doing this listing. Oh, there's 12 to 21, 28 to 49, 28 to 49, 32 to 56. So I actually wrote the table, the answer, a little different than what they had. But this is what we're looking at here is basically what I did. I just put it on the wrong lines. Okay. It's just listing all of them if you go back. This is them right here. I think 4 of them, I believe. And then remember, table B was not a ratio table, so that's why they put not a ratio table here. And then if you were going to look at the equivalent ratios for C, they're listed 2 to 9, 8 to 36, 16 to 72, 10 to 45, 10 to 45, 14 to 63, 6 to 27, 12 to 54. And then table D was not a ratio table. So again, all I really want you to do is number 8 here, A. So the work in school for Monday would be this. Unit 1, 9, homework. It wants you to make a ratio table for each situation and then also to label the columns. And then here's problem number 1, 2, and 3. So really you're completing the ratio table and then the linking unit is. So I won't finish number 1, but it says Noreen and Tim each plant groups of flowers in their gardens. Noreen plants 3 in a group while Tim plants 5 in a group. So you would start filling it in. You have your unit ratio of 3 to 5, and 3 would be Noreen, and 5 would be Tim. And then you would continue and then fill out the linking unit. And then the remembering side of 1.9, more factor puzzles. 10 to 12, you'd have to find a number that would go into 10 that would also go into 12. So hopefully you recognize that 2 would go into both. 2 goes into 10 5 times, 2 goes into 12 6 times, and then you just got to finish it. Fill in the missing values in the rate table and then draw the graph. So in this rate table, number of pounds, cost in dollars, 1, 2, 3 to 6. So if 3 pounds is $6, how much is 1 pound? That's what you'd have to figure. So 3 goes into 6 2 times. So your basic unit rate would be $2 for 1 pound. Okay? 2 pounds then would be $4. 4 pounds then would be $8. And now they want you to graph it over here. Okay, so remember you have your label here and your label there, number of pounds, cost in dollars. So let's look at it here. So here's the number of pounds, 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, and so on. And then you have your label, and it is crucial that you label cost in dollars, number of pounds. So 1 pound costs $2. So you make your plot. 2, $4. There's 2, and there's 4. Make your dot. 3, 6. There's 3 and 6. There's 4 and 8. Connect the dots, and you've completed your graph. All right, draw a line in your black notebook. Let's look at lesson 10, seeing proportions and ratio tables. Page 27 is what I would like you to write in your notebook. And let's get started. Two equivalent ratios make a proportion. Any two rows from a ratio table makes a proportion. In a proportion problem, one of the four numbers is unknown. Solving a proportion means finding that unknown number. Proportion problem. Grandma made applesauce using the same number of bags of red apples and bags of yellow apples. Her red apples cost $6 and her yellow apples cost $14. I used her recipe but made more applesauce. I paid $35 for the yellow apples. How much did my red apples cost? Okay, so the problem can be solved by solving this proportion. 6 to 14. $6 to 14. But then I paid $35 for my yellow, which is 14, 35. How much did I pay for my red apples? So this is where you get get 6 to 14 is equivalent to C, the 35, and you're trying to solve for C. It says to solve the proportion, you need to find the value of C. So over on the right, you have your ratio table that will need to be completed. Here's your red apples. Here are your yellow apples, 1 bag, 2 bags, 3 bags, 4 bags, and so on. Fill in the ratio table for the problem. Circle the rows of the ratio table that make up the problem. So you're going to be looking for the 614, 635, or C35. What is the value of C? What is the solution to the problem? That's what we're going to be working on. So in your black notebook, draw the ratio table. We're going to be answering 1, 2, and 3, and let's get to it. So let's take a look at 1, 2, and 3 filled in. Fill in a ratio table for the problem. So here we go. Over on the right, there's your problem. Let me move this stuff around here. 3 to 7. What did I come up with the 3 to 7? Well, we have to figure out, remember back in the problem, it says her red apples cost $6 and her yellow apples cost $14. So 1 bag, down to its unit rate, you would take 2 into 6 and 2 into 14, and that would get you red 3, yellow 7. Okay? Bag 2 would be the 6 to 14. You would circle the 6 to 14 because it's in your problem here. Okay? It's increasing 3, 6, 7, 14, 9, 21, row 4, 12, 28. Now, row 5, here's your 35, and there's your 15. And you notice they circled it because your 15 would be your C. Row 6, 18 to 42. Row 7, 21 to 49. Row 8, 24 to 56. Row 9, 27 to 63. Fill in the ratio table. Complete that. Circle the rows of the ratio table that make up the problem. Right there and right there. Notice they boxed 15 because that's the value of C. And then the final answer would be, what is the solution for the problem? $15. by definition, proportion means an equation stating that two ratios are equivalent. The first ratio is equivalent to the second ratio. All right, let's take a look at this page here, problem number 4 through 6. I'm trying to move this out of the way, but I don't think I'm going to have any luck with it. Looks like you have a factor puzzle over here. You know how to solve factor puzzles. It is faster to make a factor puzzle than a whole ratio table. Write the numbers from the proportion problem in the factor puzzle. Solve the factor puzzle. So 6, 14, 35. So remember, this would be your C. Well, 6 and 14. We know that 2 will go into 6 and 2 will go into 14. So 2 and 3 and 2 and 7. Bringing them down. Okay. 35 divided by, oops, bring that over too. 7 is 5. 5 times 3 is 15. So just another way of solving it. Where in the ratio tables are the numbers above and below the factor? Well, again, you have the 6, 14, and 15 to 35. Where in the ratio table are the numbers to the left and to the right of the factor? Left and to right. And it says write these two numbers with the multiplication sign to the left of the yellow column in the ratio table. And that's just going back to that table. Where in the ratio table is your answer? Well, here's your answer right there. So in your black notebook, I'm just going to shoot this up on the screen here. And it says where in the ratio table is answer? You're right there. It would look like this. So in your black notebook, you should have the factor puzzle completed. Notice they put a box around the 15 because that's the C, the variable. And it says where in the ratio table the numbers above and below the factor in the first row and the column, and the ones row and the column numbers at the top. Okay. Where in the ratio table the numbers to the left in the yellow linking multiplication column labeled bags, and then write the two numbers with the multiplication sign to the left of the yellow column in the ratio table, and where in the ratio table is your answer, and then it says right here. Now if you go back to this page here, you can see what they were talking about there, right here. All right, let's take a look at the next page. So you should have this again in your notebook, 4, 5, 6, and 7. Just write the answer and complete the factor puzzle. All right, page 28, getting close to the end here. Solve proportion problems. Use factor puzzles to solve these proportion problems. Noreen and Tim both do these activities for the same amount of time, but at their own constant rate. So they both have their separate constant rate. Here's your factor puzzle. Here's your ratio table. We are to solve both. 8A. Noreen saved $20 while Tim saved $35. When Noreen has 24, how much will Tim have? So if you were going to plug this in for Noreen and for Tim in a factor puzzle, it's 20 to 35. And then it says when Noreen has saved 24, here's your question mark. Okay? Over on the ratio table, we need to find the same information out that we're finding in the factor puzzle, but we need to represent it on a ratio table. So, how much will Tim have saved? We're looking for what's the question mark, and it says, what is the question mark? And it says letter B, fill in the ratio table, circle the rows that make the factor puzzle, and write the multiples for those rows outside the table. So again, your job is to complete both. And then number 9 says, while Noreen plants 6 tomato plants, Tim plants 10 tomato plants. When Noreen has planted 21 tomato plants, how much will Tim have planted? So again, using a factor puzzle, for number 9, you have 6 tomato plants to Tim's 10. So 6 to 10. When Noreen has planted 21, how much will Tim have planted? All right, so work 8, factor puzzle, ratio table, fill it in, and then number 9 here. All right, let's take a look. 8a, 5 times 4 is 20. 5 times 7 is 35. Make sure you bring it across. 6 times 4 is 24. Bring it across. So 6 times 7 is 42. So there's your answer. So they boxed it in. Now over here on the ratio table, it's 4 to 7. That's your unit rate, 4 to 7. So you start out with 4 to 7. 8 to 14. 12 to 21. 16 to 28. Again, 7 plus 7 plus 7, or 7 times 2, 7 plus 7 plus 7, or 7 times 3. Then you get times 5. 4 times 5 gives you that 20. 7 times 5 gives you that 35. So they circle that. And then if you look at Noreen's column, the next one is 24. Multiplied by 6. 4 times 6 is 24. And then 7 times 6 is 42. So there's your answer in there as well. And I guess really I thought before in the previous problem they actually boxed the 42 as well. Down below, number 9, 6 to 10. 2 times 3 is 6. 2 times 5 is 10. 7 times 3 is 21. 5 times 7 is 35, and you can see that they boxed the 35. All right. Number 10 and number 11, let's just do one more, and then we'll be done. Let's look at number 10 here. When Noreen had collected 6 stickers, Tim had collected 21. So we have 6 to 21. Yeah, that didn't work out so well, did it? 6 to 21. What number will go into 6 that will also go into 21? We're looking at factors of 6 are 1, 2, 3, and 6. 3 goes into 6 and 3 goes into 21. So 3 times 2 and 3 times, or 21 divided by 3 is 7. Okay? Oh, I didn't finish this. How many stickers will Noreen have when Tim has 56? So Tim has 56 down here. I need to add that, and we're trying to find out what this answer is right here. Bringing the 2 down, bringing the 7 down. 56 divided by 7 is 8, bringing it 8 over. 8 times 2 is 16. So your answer would be 16. So solve number 10 in your black notebook. And if you look, here's the completed one, a little bit nicer. 2, 7, 16 is box, 16 stickers. So for the second part of your classwork, you'll have the homework. You can see here on 110, they're going to want you to make a factor puzzle, and they are also going to want you to make a ratio table. And you'll have 1, 2, 3, 4, and 5. On the remembering, more factor puzzles, and then solve each rate problem. Just basically more of the same what we've been doing. This concludes Lesson 9 and Lesson 10. And like I said, on Monday we will work on the schoolwork and complete 1.9 and 1.10.